1.3 Average Rate of Change. Southwestern College, Professor Maria Olivas. Average rate of change. Objectives. Compute an average rate of change. Find a simplified difference quotient. 1. Average rate of change. Consider the following situation. The average cost of owning and operating a car in the U.S. is approximated by C of t equals 0.06 t squared plus 0.74 t plus 37.3 when t is greater than or equal to 0 and t is less than or equal to 11, where C of t is measured in cents per mile, and t is measured in years with t equal to 0 corresponding to January 1st, 1991. A. Sketch the graph. So we're going to begin by sketching a graph. I'm going to draw a coordinate plane with an x-axis and a y-axis. Let me go ahead and put a cloud around where it says t is measured in years with t equal to 0 corresponding to January 1st, 1991. And I'm going to label the x-axis with t, and then in parentheses next to the t, I'm going to write years. I'm going to start off by labeling at the origin 0 for t, and I'm going to write down January 1st, 1991 with an arrow pointing at that 0 so I remember that that 0 represents that date. I'm going to go ahead and draw tick marks on the t-axis. So I'm going to draw tick marks on the t-axis from 0 to 11 by a scale of 1. And I'm going to go ahead and label those tick marks 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now I'm going to put a cloud around C of t is measured in cents per mile. This tells me how to measure my y-axis. I'm also going to put a box around average cost because I know that's what C of t represents. I'm going to go ahead and label the y-axis with C of t. And I'm also going to write down the units that are represented by the C of t axis, which represents cost per mile. Cost, we usually represent cost in terms of dollars, but in this case, they're telling us that this is represented in cents. So I'm going to make sure that I put a cent sign over miles to represent cents per mile. Now for the y-axis, I'm going to go ahead and draw tick marks on that axis as well for C of t. I'm going to go by a scale of 10. So I'm going to start at 0 and I'm going to go 10, 20, 30, 40, 50, 60, up to 70. So it'll be from 0 to 70 on C of t by a scale of 10. On the right hand side, I'm going to draw a 2-column chart to represent my table of values that I'm going to use to help me sketch my graph. I'm going to label the first column with t and the second column is going to represent C of t. For t, I'm going to choose values such as 0, 4, 9, and 11. When I substitute 0 into the equation, I'm going to get 37.3. When I substitute 4, I'm going to get 41.22. When I substitute 9, I'm going to get 48.82. And when I substitute 11, I'm going to get 52.7. Now that I have my points, I'm able to go ahead and plot these points. You can get these points by using your graphing calculator and inputting your function and evaluating the function for these values. You can also get them from the table of values from your graphing calculator. So I've gone ahead and labeled the y-intercept at 0, 37.3. My next point, 4, 41.22, and I'm drawing some dashed vertical and horizontal line segments coming from the axes just to help guide me to plot the point. I will be erasing those dashed line segments. And then we're going to plot 9, 48.82, and our last point is going to be 11, 52.7. I'm going to go ahead and erase all of these dashed little line segments that I drew in order to help guide me in plotting the points. Now I'm going to go ahead and draw a curve through the points And I'm going to make sure that I do not extend this curve. It does have a beginning point and like an end point, because they did tell me the domain of this function. It's from 0 to 11. So I'm going to go ahead and label each point with its corresponding ordered pair. So the first one, 0, 37.3. The second one, 4, 41.22. Third one, 3, 48.22. And the last one here is 11, 52.7. So now I have my graph that represents the function that we mentioned earlier in our problem. Let's go ahead and answer B. What was the cost of driving a car in 1991? I know 1991 represents t equal to 0. So I'm going to go ahead and look here, and the y-intercept, I'm going to get that y-coordinate value from the y-intercept. That's going to be 37.3. And because it's a word problem here, I'm going to label it with units. It's 37.3 cents per mile. Now I'm going to go ahead and just write in the years for each one of these t values. For 1, I'm going to write in 1992. For 2, I'm going to write in 1993. For 3, I'm going to write in 1994. For 4, I'm going to write in 1995. For 5, 1996. For 6, 1997. For 7, 1998. For 8, 1999. For 9, 2000, 10, 2001, 11, 2002. Now going back to B, in 1995, and I've circled in 1995, drawn an arrow pointing down to t equals 4 because I know it represents t equal to 4. It's going to be 41.22 cents per mile. I'm just going to go ahead and lasso in the part that represents the sketch of the graph and the table. I'm going to shrink it and just center it here in the section that's provided for part A where it says sketch the graph, so that it doesn't take up so much space. Now we're ready to go move on to part C. What was the average rate of change in the cost of driving a car from 1991 to 1995? So I'm going to highlight the part that says average rate of change, and I'm going to draw a cloud around those words. Underneath it, I'm going to write down the word slope because that's what average rate of change represents. It represents slope. So I know I'm going to have to use the formula for slope. I also know I'm going from 1991 to 1995, so I'm going to circle in those years right there so I know I'm focusing in with those values and looking for those ordered pairs that represent those times. So the two ordered pairs I'm writing down is 0, 37.3 and 4, 41.22. Now I'm going to write down m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I'm going to label the coordinates of my ordered pairs. The first one, the 0, 37.3, I'm going to label the 0 as x sub 1 and the 37.3 as y sub 1. In the second ordered pair, the 4, 41.22, I'm going to label the 4 as x and the 41.22 as y sub 2. Now I'm going to substitute into my formula. So where I wrote my formula from slope, right after that I'm going to write equals 41.22 minus 37.3 over 4 minus 0, which equals 3.92 over 4, which equals, and if I do that division, I'm going to get 0.98 cents per mile per year. And I'm going to box that answer in. Now we are ready to move on to question D. Looking at the graph, do you think the cost of driving a car was increasing faster in 1991 or in 1995? I'm going to start off by highlighting the part that says increasing faster in 1991 or in 1995, so that I know what I'm focusing on in this question. I'm going to go and highlight those points back in my sketch. So I highlighted the point that represents 0, 37.3 and the point that represents 4, 41.22. Looking at those 2 points in the year 1995, at that point, you can tell that the graph is steeper. I know it is difficult to tell with certainty by just looking at the graph, and that is why later on we are going to be learning other methods that are going to be able to tell us that rate of change in that exact instant. But for now, we're just going to look at the graph and look to see where the graph is steeper. So we're going to write down for D the cost of driving a car was increasing faster in 1995. And we can tell this because the graph is steeper. I'm going to underline the word steeper. I'm going to draw an arrow pointing towards it, and inside parentheses next to that arrow, I'm going to write down, this is because this is where the slope is greater. I'm going to close the parentheses. E. What was the average rate of change in the cost of driving a car from 1995 to 2000? Once again, here we are going to use slope. I'm highlighting the words average rate of change. Those words, average rate of change, I'm also going to draw a red cloud around them and an arrow pointing down towards the word slope. I'm circling 1995 and 2000. In order to find slope, once again, I need 2 points. So I'm going to need the point that represents 1995, which is 4, 41.22, and the point that represents the year 2000, which is 9, 48.82. I'm going to label the point 4, 41.22 with x sub 1 and y sub 1, the x sub 1 above the 4 and the y sub 1 above the 41.22, and I'm going to label the point 9, 48.82 with x sub 2, y sub 2, with the x sub 2 above the 9 and the y sub 2 above the 48.82. So now we're ready to find slope. Slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And this is going to be equal to, here I'm going to substitute the values from my ordered pairs, the coordinates. So it's going to be c of 9 minus c of 4 over 9 minus 4. Now we are going to replace c of 9 and c of 4 with their corresponding y coordinates. So c of 9 is equal to 48.82 minus c of 4 is equal to 41.22 all over 9 minus 4, which is equal to 5. So this is going to be equal to 7.6 divided by 5. And I'm just going to go ahead and do this in the calculator, and I'm going to get 1.52, and we're going to label the units as cents per mile per year, and we're going to box that answer in. Now we're ready to move on to example number 2. The graph below shows the percent of new employees at a particular company from 2000 to 2009. Estimate the average rate of change in the percent of new employees over the following time periods. First, let me describe the graph that we have here in front of us. Here we have a coordinate plane focused in quadrant 1. On the x-axis, we have the years. We have from 2000 to 2011 separated by a scale of 1, with the years 2000, 2005, 2009 clearly labeled. On the y-axis, this represents the percent of new employees. We have tick marks from 0 to 9 separated by a scale of 1. It is labeled with the values of 2.0, 4.0, 6.0, and 8.0. I'm drawing an arrow here at the origin point, and I'm labeling that point as 2000, 0. I'm also going to draw a point at 2005, 5.0 or 5. I'm also going to draw a point at 2008, 8. And one more point here, we're going to draw it at 2009, 8.5. These are the ordered pairs we're going to be using in the problem that we're going to be doing. So for A, we're trying to estimate the average rate of change in the percent of new employees over the following time periods. We're going from the time period from 2000 to 2005. I've gone and highlighted the part that says estimate the average rate of change. Remember that whenever you see those words average rate of change, you should be thinking about slope. We're looking for slope. I'm going to write down the two ordered pairs we're going to be using to represent our years 2000 and 2005. It's going to be 2000, 0 and 2005, 5. I've written down the formula for slope, which is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. For the ordered pair 2000, 0, I'm going to label the x-coordinate 2000 as x sub 1, and for the y-coordinate of 0, I'm going to label that as y sub 1. For the next ordered pair 2005, 5, I'm going to label the x-coordinate 2005 as x sub 2, and the y-coordinate 5 as y sub 2. Now I'm going to write here that this is going to equal 5 minus 0 over 2005 minus 2000. I'm substituting into the formula for slope, and this will simplify to 5 over 5, which is equal to 1. So now we need to label our units. If we look at the y-axis, we see that the y-axis represents percent of new employees. I have gone ahead and written y for the y-axis and circled it, and I've also circled where it says percent for percent of new employees. Underneath the x-axis, I have written the word years, and I have labeled the x-axis with x. So we're going to label this as the units percent per year. So it will be 1% per year. That will be the average rate of change from 2000 to 2005. We're going to go ahead and box that answer in. For B, we're looking for the average rate of change from 2005 to 2008. So we're going to use the two ordered pairs, 2005, 5 and 2008, 8. I'm going to label the x-coordinate for the ordered pair 2005, 5. So the x-coordinate 2005 as x sub 1 and the y-coordinate 5 as y sub 1. I'm going to label the x-coordinate for my second point, which is 2008, as x sub 2 and the y-coordinate as y sub 2. Now I'm going to write down average rate of change is equal to, I'm going to write 8 minus 5 in the numerator over 2008 minus 2005 in the denominator. This is going to be equal to 3 divided by 3, which simplifies to 1. Once again, this answer is going to be 1% per year for our average rate of change in the percent of new employees over the time period 2005 to 2008. For C, we're looking for the estimate of the average rate of change in the percent of new employees from 2000 to 2009. So I'm going to write down the two ordered pairs 2000, 0 and 2009, 8.5. I'm going to label my first ordered pair, the x-coordinate 2000 as x sub 1 and the y-coordinate as y sub 1. I'm going to label the x-coordinate for my second ordered pair, which is 2009, as x sub 2, and my y-coordinate 8.5 as y sub 2. Once again, I'm going to write down average rate of change is equal to, I'm going to write in the numerator 8.5 minus 0 over 2009 minus 2000. This is going to be equal to 8.5 divided by 9, which is equal to 0.94 with the repeating bar over the 4. And we're going to label the units as percent per year, and we're going to box that in. The average rate of change. The average rate of change of f of x with respect to x as x changes from x to x plus h, also called the difference quotient, is given by, I'm going to write down the words average rate of change, and in parentheses underneath that, I'm going to write down or the difference quotient equals f of x plus h minus f of x in the numerator divided by h. I'm just going to lasso that and shrink it a little bit and just bring it down a little bit so it looks a little more centered. I'm going to lasso everything that I just wrote down here for average rate of change, lasso the whole thing and just shrink it and center it a little bit more. And then I'm going to put a box around this. This is a very important formula. We need to make sure we memorize it. So I'm just making sure I give it plenty of emphasis here. Note that this is the slope of the secant line from x to x plus h. Let's draw a picture to represent this. I'm going to draw a coordinate plane here with the focus primarily in quadrant 1. And for the y-axis, I'm going to label that as f of x, and the x-axis is going to be labeled as x. I'm going to go ahead and draw a curve So this is a curve that is concave down and it is increasing. I'm going to label my function as y equals f of x. I'm going to label 2 points that are on this curve. So the first point, I've gone ahead and drawn a point on the curve that is closer towards the left-hand side, and I'm going to label that ordered pair as x, comma, f of x. I'm going to draw a dashed line segment down from that point to the x-axis and label that as x on the x-axis. And I'm going to draw a horizontal line segment that is dashed from the point to the y-axis, and I'm going to label that y value as f of x. The second ordered pair that I'm going to label here for the point that is further towards the right is going to be x plus h, comma, f of x plus h. I'm going to draw a dashed line segment going down from that point to the x-axis and label that as x plus h. And I'm going to draw a dashed line segment from that point to the y-axis and label that value there as f of x plus h. I'm going to connect my 2 points with a red line segment. This is going to represent our secant line that's connecting our 2 points. Or I should say secant line segment. Now I'm going to go ahead and write slope on the right-hand side of the screen. I'm going to say slope equals m, which equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Next line here, I'm going to write m equals, instead of y sub 2, I'm going to substitute that with f of x plus h minus f of x for y sub 1 over x plus h minus x. Underneath that, we're going to write down that this is equal to f of x plus h minus f of x over, and I'm just going to write down an h here. I'm going to highlight the x's that were in our denominator up above. We had an x and a minus x, and I highlighted those and I drew red little lines through those to cancel them out. So now I just wrote h in our denominator, and I'm putting this as equal to the difference quotient, because that's what we refer to this to. This is called the difference quotient. I'm going to go ahead and box that in. Let's go on to example number 3. Given f of x equals x squared minus 5x, find the average rate of change from a x equals 1 to x equals 2. I'm going to highlight the words average rate of change. This tells me that I need to find slope. In order to find slope, I need 2 points. I'm going to draw an arrow pointing to the right here, and I'm going to write down the 2 following ordered pairs, 1 comma f of 1 and 2 comma f of 2. Now I'm going to substitute into the formula for slope. I'm going to write down f of 2 minus f of 1 over 2 minus 1. In order to finish this problem, I need to evaluate the function at f of 1 and f of 2. At f of 1, the function is going to be equal to 1 squared minus 5 times 1. So f of 1 is equal to 1 minus 5 equals negative 4. F of 2 is equal to 2 squared minus 5 times 2. So f of 2 equals 4 minus 10, which is equal to negative 6. I can now substitute these values for f of 2 and f of 1. So f of 2 minus f of 1 over 2 minus 1 is equal to negative 6 minus a negative 4 over 2 minus 1. This is going to be equal to negative 6 plus 4 over 1, which is equal to negative 2 divided by 1, which is just going to be equal to negative 2. I'm going to go ahead and lasso the work that I did here in order to move it slightly to the left, and that way I can write it equals negative 2, and I have enough space to write that in here on the right. I'm going to box in my answer of negative 2. This represents my average rate of change. B. We're going to find the average rate of change from x to x plus h, and we're going to make sure we simplify this. So I'm going to write down f of x plus h minus f of x over x plus h minus x. Once again, this is going to simplify to f of x plus h minus f of x over h, which represents the difference quotient. In order to do this problem, I need to know what f of x plus h is equal to. I already know that f of x is equal to x squared minus 5x, but I do not know what f of x plus h is equal to. So I'm going to write down f of x plus h equals x plus h quantity squared minus 5 times, we're going to open up a set of parentheses, x plus h, and close our parentheses. Let's go ahead and simplify this. F of x plus h equals x plus h times x plus h, then minus 5 times x plus h. F of x plus h is going to be equal to x squared plus 2xh plus h squared minus 5x minus 5h. I'm going to go back up to where I had written f of x plus h minus f of x over h, and I'm going to set that equal to, I'm going to draw a pretty big fraction bar here, and on the numerator, in the numerator, I am going to write x squared plus 2xh plus h squared minus 5x minus 5h. This represents f of x plus h. Now I'm going to subtract from that. Inside parentheses, I'm going to write x squared minus 5x over h. Now I'm going to write that this equals, I'm going to draw a big fraction bar to make sure I have enough space here to write everything. In the numerator, I have x squared plus 2xh plus h squared minus 5x minus 5h minus x squared plus 5x over h. So we look to see if there are any like terms that we can combine. I see here, I'm going to highlight in yellow that I have an x squared and a negative x squared. So I can cancel those out. I'm going to draw little red lines through them to cancel them out. And I'm going to highlight in green here, negative 5x and positive 5x. And those will also cancel out. So I'm going to go ahead and draw little red lines through those two to show that I'm canceling them out. Our next line here, or beneath what I just wrote, I'm going to write this equals 2x plus h. I'm going to write in the numerator 2xh plus h squared minus 5h over h, and this is going to be equal to, before I write down what this equals, let me lasso in all the work I've done here for part B. I'm going to shrink it towards the left-hand side of the screen so I have a little bit more space. Now I have enough space to write my fraction bar. And in the numerator, we're going to be left with, I'm going to factor out an h. So it'll be h times, we're going to open up a set of parentheses, 2x plus h minus 5, close the parentheses, over h. I can now cancel out that common factor of h in the numerator and the denominator. So that's what I'm going to do next. I'm going to go ahead and cancel out by drawing a little red line through it. And I'm writing a 1 because remember, when you cancel out, you're dividing that factor out and you're being left with a factor of 1 in its place. So our final answer is going to be equal to 2x plus h minus 5. I'm going to box that in. That's going to represent the average rate of change from x to x plus h. All right, we're ready to move on to our next example. Let's go on to example number 4. Find the simplified form of the difference quotient for f of x equals 2 over x. I'm going to recopy my function, f of x equals 2 over x, and beneath it I'm going to write f of x plus h is equal to 2 over x plus h, We're just substituting x plus h in place of x. Now we're going to substitute into that difference quotient. So remember the difference quotient. I'm going to first lasso in the work that I wrote in here, the two functions that I wrote down. I'm going to shrink them, and I'm going to move them over to the upper right-hand corner of the screen. So that way I have more space to do my work. I'm going to write down f of x plus h minus f of x over h. This represents the difference quotient. So I'm going to substitute into this. So this is going to end up giving me 2 over x plus h minus 2 over x all over h. I have a complex fraction here that I need to simplify. So I'm going to simplify this complex fraction by multiplying through by the LCD to the numerator and denominator. I'm going to multiply the numerator by x times x plus h over 1. And I'm going to multiply the denominator by x times the quantity x plus h. So next we're going to be left here with 2x minus 2 times the quantity x plus h over hx times the quantity x plus h. I'm going to distribute that -2 that we have in the numerator, and we're going to be left here with that this is equal to 2x minus 2h in the numerator all over hx times the quantity x plus h. And this is equal to -2h over hx times the quantity x plus h. I'm going to highlight the h's that I have in the numerator and denominator and cancel them out since they are a common factor. Draw a red line through them and write 1s since they divided out. This is going to be equal to -2 over x times the quantity x plus h, and that's going to be our final answer, and we're going to box that in.